Imagine a healthy 40-year-old woman sitting in a sterile doctor's office. Her physician walks in and delivers terrifying news. Her routine mammogram came back positive for breast cancer. Here are the statistics for a woman of her age. The probability of actually having breast cancer is 0.8%. If a woman has cancer, the test detects it 90% of the time. But if she doesn't have cancer, there is still a 7% chance the test will come back positive anyway. When researchers presented those exact numbers to the chief of a university teaching hospital, he spent 10 minutes agonizing over the math. His final conclusion? He told them the woman had a 90% chance of having cancer. He was completely wrong. The actual mathematical probability that this woman has breast cancer is roughly 9%. The department chief isn't incompetent. His mistake is the result of a cognitive glitch in how the human brain processes abstract probability. We are culturally conditioned to view modern scientific testing as a machine that produces flawless, binary answers. You either have the disease or you don't. Think about fingerprinting. For over a century, the courts have treated a matched print as absolute, infallible proof of guilt. This desire for absolute proof collides with a widespread condition called innumeracy, the human inability to intuitively grasp statistical risk and uncertainty. Over 100 years ago, the science fiction pioneer H.G. Wells predicted that statistical thinking would eventually become as necessary for efficient citizenship as the ability to read and write. When public innumeracy meets our deep craving for certainty, the result is a system where patients make life or death decisions, completely blind to the actual risks they face. The medical system communicates risk using conditional probabilities, a mathematical format that expresses the chance of one event occurring, given that another event has already happened. Our evolutionary brains simply are not built to decode them. Look at this equation. This is Bayes' rule, the exact mathematical formula required to solve the mammogram puzzle. It creates immediate cognitive overload for almost anyone who isn't a trained statistician. There is a cognitive fix. We can bypass the math entirely by translating the exact same data into natural frequencies, which are simple, easily countable numbers of physical events. As this diagram shows, if we start with a sample of 1,000 women, exactly 8 of them will actually have breast cancer. Of those 8, 7 will correctly receive a positive test result. But look at the other 992 women who are perfectly healthy. Because of the test's error rate, roughly 70 of them will receive a terrifying false positive. Now, group all the positive tests together. Out of the 77 total women who tested positive, only 7 actually have cancer. The 9% reality is instantly obvious. Changing the external representation of the data removes the mental block. We don't need to get better at math. We just need to look at the numbers in a format our brains recognize. Unfortunately, public health organizations frequently exploit this cognitive glitch. They use confusing statistical formats to market certainty. You will often see a bold headline claiming that routine mammograms reduce breast cancer deaths by 25%. That 25% is a relative risk, a metric that describes the percentage drop in an event compared to a previous baseline. It artificially inflates the perceived benefit of a medical procedure. To see the unedited reality of the numbers, we have to translate that claim into absolute risk, the actual raw difference in the number of events that occur. This chart shows the absolute truth. If 1,000 women participate in screening over 10 years, the number who die from breast cancer drops from 4 women down to 3. The difference is one single life saved out of 1,000. Amplifying the relative risk obscures massive hidden costs. Out of those same 1,000 women, hundreds will receive false positives, leading to months of severe psychological trauma, unnecessary biopsies, and invasive treatments for cancers that never would have progressed. Presenting marketing statistics in place of absolute risk and natural frequencies denies patients the clear information they need to give true informed consent. The medical data clearly shows that mammography screening does save lives, particularly for women over the age of 50. The goal here is not to skip screenings. It is to shatter the illusion of certainty so you can weigh the actual physical and emotional costs against the real medical benefits. You can force this clarity yourself. The next time a doctor cites a percentage or a relative risk for a test or procedure, stop them. Ask them to translate the risk into a natural frequency with one simple question. Out of 100 people exactly like me, how many will experience this? Living safely in a modern medical world doesn't mean finding absolute certainty. It means learning to read the risks clearly enough to make your